Welcome to the periodic table. Make sure you have your reference tables close by. Make sure you have that near you. Luckily, the periodic table is mostly something that we reference, but there's a little bit of information you need besides just using your reference tables. How about a little bit of history? So this guy, Dmitry Mendeleev, there he is. Dmitry Mendeleev was born on the same day I was, February 8th. Sometimes they call him the father of the periodic table. Dmitry Mendeleev was the first person to arrange elements in order of increasing atomic mass. So before then, people were trying to come up with other ways to arrange the periodic table. They had lots of different ideas. He was the first one to say, okay, atomic mass is going to be how we do it. And he came up with this brilliant kind of grid structure. It was a snowy weekend. He kind of got it all done. He laid them out, these elements, on cards, and he was kind of shuffling the cards around. He knew that something called oxygen combination ratios played a factor in there too, and atomic mass, which he called atomic weight at the time, and he just kind of set them up. And he noticed as he set up increasing atomic weights or mass, other properties increased or decreased as you went across or down. And so he saw that these trends were kind of popping out at him. He also noticed that there were places where the trends kind of stopped. He noticed that there were going to be blanks. And so he decided that he would just leave those blanks. He would leave spaces for elements not yet discovered according to those other properties. And sure enough, years later, he was able to, or scientists were able to find these elements and put them in the right spots. So you might notice that our current periodic table is not arranged by atomic mass, although it does increase. It's not the way we arrange our current periodic table. Our current periodic table is arranged by atomic number, which can be attributed to this person, Henry Moseley. Unfortunately, he died tragically in World War I, but before he did, he was a scientist. And he said, well, we're going to use atomic number. Atomic number is basically the same thing as number of protons, and that's unique to every element. Nobody can have the same number, so we're going to keep that as how our periodic table increases. And he noticed that that was a better way. Yes, the masses generally do increase at the same time, but not always. And so this is how our modern periodic table is arranged. So what does it mean to be periodic? That means it repeats, something repeats. Let's say every Tuesday you have tacos, Taco Tuesday. So you know that every Tuesday come back around, you're going to have tacos. I know for me, every Sunday I go grocery shopping. So Sunday, I'm at Wegmans. The next Sunday, I'm going to be at Wegmans. It's a repetitive event. So that's the same idea with periodic table. We have trends. We have properties of elements, both physical and chemical, and they repeat as you go across the periodic table. So when elements are arranged in order of increasing atomic number, there's a periodic repetition of physical and chemical properties. So you're going to start off with elements that are very malleable, that are good conductors, and as you travel across the periodic table, they become less and less able to conduct, and then they become not able to conduct, and then you come back around, and then they are, and then they're less and less, and then they're not, and then they are. So we've got these trends that repeat. That's called periodicity or periodic law. So there are three main categories of elements, and those are called metals, nonmetals, and metalloids. So let's take a look at our periodic table for a second. This looks a little bit different than yours. This is also there. There's this like zigzag line here, staircase. And remember, these two come from here. All right, so let me get rid of that. So the first category of elements are called the metals. And maybe you can see some of these, it indeed does say metals. So I'm going to color in my metals. You don't need to do any coloring just yet. These are all metals. These are all metals. And be careful, aluminum is a metal, so is gallium, but not everybody. So I'm going to be careful. Boop, boop, boop. Yeah. Okay. So these are metals, and perhaps you're familiar. Metals the majority of the periodic table, the left side, they are good conductors of heat and electricity. So they allow heat and electricity to pass through. That's why we'd use something like a metal frying pan, because you'd put your food here, heat would go through. Notice in this picture we have a wooden handle so that you don't get your hand hot. Luster means shiny, so metals are shiny. Malleable means you can bend and shape them. And ductile means you can pull into thin wire. Very messy, I apologize. So here's a picture of sodium metal. It's very malleable. It's like cream cheese. You can cut it with a butter knife. Very shiny. You could pull it into wire. We make copper wire. That's another metal. So most of the elements in the periodic table are metals. Be careful, hydrogen is not. Hydrogen is what we call a nonmetal. So they are the smaller portion of the right side of the table, the right side, including hydrogen. We'll talk about why hydrogen is living over on the left a little bit later. These are the opposite of metals, so instead of conducting, they are insulating. They're holding heat and electricity in. They are poor conductors. A lot of these elements are not solids. They are liquid and gases. But the solids that we do have are not malleable. They're brittle and they're dull. So make sure you know those are for solids only. So here's an example of a non-metallic solid. This is sulfur, and it won't bend. It will just shatter into this powder. So going back here to our periodic table, if I wanted to color in the non-metals, that would include hydrogen, and not those guys along the zigzag. Okay, so those would be our, I guess I should put a data key, non-metals. What color were you? You were pink, metal. All right, so then I have left some along the zigzag as not colored in. So that's our third category, known as the metalloids, sometimes known also as semi-metals, which should tell you that they have properties of both, similar to both metals and nonmetals, depending on who they're bonding with, conditions. So if you think about it, it's kind of like a border town between countries. You'll have influences coming from both sides. So if you think about a border between the United States and Mexico, you're going to have influences of culture from both sides, food, language, music, dress, all that kind of stuff. So these are the ones along that zigzag or staircase, with a couple exceptions. Aluminum is along the staircase, but hopefully you know that is a metal. And the ones towards the bottom, those are radioactive. We don't include those. So these are the ones that we will consider the metalloids: boron, silicon, germanium, arsenic, antimony, and tellurium. So if we were to go back here, choose my last color, and I'll color these in. They're a border between the two. These would be our metalloids, and you do not need to color in yours because we're going to be coloring them in a little bit differently. Okay? Hope that helps. Thank you.